Hello everyone and welcome to Kognito Key. I am so absolutely thrilled to have you here today. In this explainer, we're going to unravel a really fascinating piece of technology that you use every single day, probably without even realizing it. We're talking about mobile IP. It's this brilliant protocol that keeps all your devices connected to the internet while you're constantly on the move. So let's dive right in.
To really get why mobile IP is such a game changer, we first have to take a look at traditional IP addresses. You see, the original Internet protocol was really designed for stationary hosts. It completely assumes your computer just stays plugged into one specific network. The first part of your IP address identifies your network, and the second part identifies your device. But what if the host physically moved to another network? Imagine walking out of your favorite coffee shop. Suddenly, that old IP address is completely invalid, and your data connection drops instantly.
Section 1. The static IP problem and its solution. In the early days, engineers proposed two main solutions to fix this. Solution 1 was simply changing the IP address every single time you entered a new network. But honestly, this was a total nightmare. I mean, nobody wants to reboot their phone just because they walked into a new room, right? It meant updating these massive DNS tables and interrupting literally all your active downloads. Solution 2, however, was far more elegant. Just give the host two addresses: an original, permanent address, and a temporary one for whatever new network it joins.
And that second solution is exactly what gave birth to mobile IP. It's essentially an improvised version of the standard protocol. It gives your mobile host a permanent home address that absolutely never changes, and a temporary care of address that updates the very second you step into a foreign network. It's just a brilliant two-address system that lets you migrate networks without dropping your connection to remote hosts.
Section 2. The cast of characters, or key entities.
Okay, so our cast of characters features four main players. First up, we have the mobile host. That's your phone or your laptop. Then we have the remote host, which is the server or person you're actually communicating with. But the real magic happens with the agents. The home agent is a specialized router sitting in your original network, and the foreign agent is a specialized router in your new network. They work together to handle the traffic handoff and keep you connected.
Section 3. The mechanism, which is a three-phase process.
Whenever a mobile device enters a new network, it has to successfully establish its connection chronologically. First is Phase 1, agent discovery. Then Phase 2, registration. And finally, Phase 3, data transfer. Let's break those down.
In Phase 1, the mobile host essentially has to figure out where it is. It discovers its new care of address by listening for ICMP router advertisements. Basically, the foreign agent is out there broadcasting its presence, and if the mobile device doesn't hear it right away, it can actively send out a solicitation message to find that foreign agent and grab its temporary care of address.
Now, once the mobile host has its new temporary address, we move to Phase 2. It can't just keep that address a secret. It sends a registration request to the foreign agent, which then immediately forwards it back to the home agent. This step officially registers your new location so your home network knows exactly where to forward your data.
Finally, we reach Phase 3, data transfer. When a remote host sends you a message, it's still using your permanent home address. Your home agent intercepts this packet, and here's the clever part. It encapsulates it. It basically puts that packet inside a brand new digital envelope addressed to your foreign agent. The foreign agent receives it, opens the envelope, and delivers the original packet right to your mobile device.
Section 4. Weighing the protocol's advantages and disadvantages.
On the plus side, obviously, mobile IP gives you a continuous, seamless connection. However, the major disadvantage here is inefficiency, specifically something called triangle routing. You see, if a remote host sends you a message, it first has to travel all the way back to your home agent before being forwarded to you. This creates extra distance and delay, even if you and the remote host happen to be sitting in the exact same foreign network.
But despite that slight detour in routing, mobile IP ensures that your movement is completely transparent to the entire internet. Thanks to this incredibly clever protocol, your physical journey across the globe remains basically invisible to the rest of the web. Your downloads don't fail, your calls don't drop, and your digital life moves seamlessly right along with you.
I really hope this explainer helped you understand the everyday magic behind your mobile connections. Please make sure to hit that subscribe button to join our Kognito Key community, and definitely like and share this explainer with others. I'll leave you with this one thought. If mobile IP makes our physical journey invisible to the web today, how will networks have to evolve to handle our movement in the future? Thank you so much for watching, and keep learning.